So this lecture is an introduction to Ivan Pavlov and his work with classical conditioning. Now, before we get started, we need to define a few things. So I've been using words like stimulus or stimuli. Stimuli is plural for stimulus is singular. These are things taken in through the senses, through afferent neurons. I'm going to be using the word stimulus a lot when we talk about Pavlovian learning, classical conditioning, and instrumental learning. So we really need to define what I mean by that. This is information taken to the central nervous system through our senses. In laboratory research, we often try to create stimuli that are very simple, really easily defined, that gather a lot of attention by the animals. The world is filled with extremely complex stimuli. We try to make them simple in the lab so we have some control over the animal's experiences. So, this might be sound, like a bell or a clicker. Oftentimes in research we use tones. Beep, right? That's a very simple stimulus. Pavlov used bells. He used a metronome. Tick, 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 tick. Metronome, right? Anything. These are auditory stimuli. They can be sight, visual. These are what I've used in my research. So when I worked with honeybees, I used stimuli that were color, that I know that the honeybee can see. They can see blue. They can see yellow very well. They can see oranges and greens. We also used stimuli that had plastic containers that had holes in them, and we put some smells inside. We took a little cotton, we put a little lemon juice on the cotton, or peppermint or something that smelled, and we created what was called a compound stimulus, which is yellow that also smelled like peppermint. Now, when I was at Oxford, I worked with birds. This is a picture of the research I did. Here's a starling, and I used stimuli that were symbols. So over here was an X, and here was a triangle or circle. These are stimuli, visual stimuli. Smell is very often used with animals. We use smell and olfactory stimuli with my honeybees, but you can also use them with rats. See, I took a little drop of peppermint and mixed it up with water, so diluted it, and then put it on a cotton ball, and then the animal could smell it, right? Lemon juice, whatever, smells are oftentimes used. You can see that a taste can be very powerful stimuli, right? So we use this with animals. Pavlov used this with dogs. He used lemon juice to elicit salivation, right? These are very powerful stimuli, but again, they're taken in through the senses. That's a stimuli. I'm going to ask you to differentiate between stimuli and responses, like on exams. Another thing that's not often thought of, but is a stimulus, is the passage of time. It can be perceived by animals. It can be perceived by humans. I might have a stimulus of 10 seconds, time passage, or 1 minute. And I'm going to give you some examples of when Pavlov I actually used time as a stimulus. Now that is kind of odd because it's not really taken in through our senses like our ears or our eyes or our fingers, but we do have a sense of time, and so time can act as a stimulus. Responses are behavior. These are actions. These are caused by motor neurons going out, muscle movements. Stimuli could come in and then cause a part of the brain to activate response centers in the salivary glands of a person or a dog. It might be eye blinking. There's a lot of responses that we use in animal behavior. Again, we try our best to define them very well so we know when the animals are showing those behaviors. What is oftentimes used in both classical conditioning and instrumental conditioning is pecking. Birds are wonderful to use in research because they have often very good color vision, many of them do, and they have responses like pecking. That's a behavior. I can measure that. In fact, what I did was in my laboratory at Oxford, when we used starlings, when it pecked something, a computer detected that. Right? I didn't have to sit there with a notepad. A computer detected when they pecked. Became very automated and very exact. So pecking behavior is oftentimes used in instrumental conditioning, but also in types of classical conditioning, which we'll talk about. Animals pressing a lever in a box like this. This is sometimes known as an operant chamber. A rat will press a lever. That's a response. It uses muscles, uses motor activity. It's something that we can record. Again, when we're looking at learning, all we can do is look at behavior and infer learning. So we better have very precise measures of behavior or responses. Stimulus, response. You need to know the difference. All right. So let's talk about classical conditioning. I've already introduced it in past lectures, but let's talk about it again. Again, in classical conditioning is procedurally different than instrumental conditioning. Procedurally, classical conditioning are when two stimuli are presented together and independent of the animal's behavior. It doesn't have to press a lever to get food. I could ring a bell and give the dog food. I could present a light to a bird and drop food. Doesn't have to do anything to get it. But they still connect them. They still associate them. Stimuli are presentation is independent of the animal's behavior, and classical conditioning can affect the autonomic nervous system, the sympathetic nervous system, parasympathetic nervous system, and the somatic nervous system. We can get muscle movement from classical conditioning. Again, instrumental conditioning, sometimes called operant. The stimuli presentation is dependent on the animal's behavior. The animal presses a lever in order to get food. That food's not coming unless they press the lever or peck the key to get food. We might have a classical conditioning experiment, which we'll talk about, where we simply present a light, drop some food for a bird, do it over and over and over again. The animal doesn't have to press the lever or peck the light to get the food. That's classical conditioning. Or we can create a contingency. The animal must do a behavior, press the lever, peck the light in order to get food. Doesn't peck the light, doesn't get food. That's instrumental conditioning. So procedurally, they're different. There are also probably different areas of the brain that are responsible for classical and instrumental conditioning, though there's some overlap. Instrumental conditioning affects the somatic nervous system. It's difficult to train an animal to affect its autonomic nervous system using instrumental conditioning procedures. You need to know the difference between the procedures. All right, so let's talk about Ivan Pavlov and classical conditioning. So Ivan Pavlov came about during a time in the 1800s, late 1800s, where we were beginning to understand psychological processes using techniques that had been used by physicists or biologists or chemists. Kind of before that, psychology was more of a philosophy. And we began to say, maybe we can understand psychological processes, behavior, learning, perception, using techniques that we use in science. So this school in psychology called the reflexive school, the reflex school, it began in Russia, emphasized the physiological basis of behavior. Again, applying physiology and biology to behavior and to learning. External or physical causes of behavior, understanding those relationships. So this was psychology as a science, the science of behavior. This was the beginning of what is known as behaviorism. Behaviorism, understanding the basic principles of learning and behavior. Now, we might differentiate between schools of behaviorism. So Pavlov and Thorndike and Hull, they were kind of mechanistic behaviorists. And then we get into people like John Watson and B.F. Skinner, who are known as radical behaviorists. We will differentiate the two in coming lectures. Now, this is a very reductionistic or atomistic approach to psychology. Reductionistic. So neuroscience tends to be reductionistic. Bring things down to the simplest level possible, as opposed to holistic, which might look at the big picture. So biology does this, right? So biology has reductionistic approaches, which is look at the cell, look at the organelle of the cell, look at the chemistry of the cell. Or they might have a holistic approach. Look at ecosystems, look at the whole planet, look at ecology, look at complex interactions of behaviors. So a reductionistic approach to psychology would be look at the basic, simplest mechanisms of learning. Holistic approach might be social psychology or developmental psychology. Look at the whole system. So Pavlov is an interesting story. I always kind of like his story because he was a physiologist, right? He was an anatomist. He worked on the digestive system. That was his career work. Very famous for it. And in fact, he did so much work on understanding the digestive system of animals, he won the Nobel Prize in Physiology and Medicine in 1904. And here he is, he's about 50 years old or so, just got a Nobel Prize, physiologist, and he changed his career. He changed his focus to do something that he's really well known for. If you ask somebody about Pavlov, and if they have a little bit of information about psychology, they're going to say, oh, classical conditioning and learning and salivating dogs. They won't say, oh, he was the guy who won a Nobel Prize for understanding how the digestive system worked. But he noticed something. In order to get the digestive system working in his animals, he used dogs, he'd have to come in and feed them. He'd feed them and he'd monitor how they salivated, and he monitored their digestive enzymes they would produce in their stomach. But things kept going wrong because he wanted to be really exact. Give the animal food and then watch the digestion of that food. And what he noticed was every time a research assistant went in there to give the dog food, the animal started salivating right then. He hadn't even given him any food. Just opening the door, walking in, and suddenly all the instruments are saying, hey, we got a salivating dog here. And that's when he started thinking, why? Why is the animal salivating? He doesn't have any food. And it was because the researcher came in every day and gave the animal food. The researcher was a stimulus that was associated with food. Every time the researcher came in, they got food. You see this with your own pets, I'm sure. Every night, I go and I get a bottle of water to have by my bed. Drink a little water during the night. So I go in and I go to my refrigerator and I put my bottle underneath the ice maker. It makes this loud noise. And then under the water, I get some water. That's a very specific stimulus. And every time I do, I give my cats some cat treats. Good night cat treats. So when they hear that sound of the refrigerator, ice maker, that's been associated night after night with getting their favorite little snacks. So I guarantee 10 o'clock at night, whatever, I'm making that ice maker work, I'm going to hear the cats come running in. Why? Because the two things are connected. They're connected. That sound and getting snacks. Okay. So he decided to change his research and try to understand this process of association using the very strict techniques that he had established in his lab for understanding salivation. Okay, so we call this connection of stimuli, this learning of connection of stimuli, classical conditioning. Sometimes it's just called Pavlovian conditioning because he did all the work on this. So, present two stimuli independent of the subject's behavior. That's methods. And here's key. They have to occur in temporal contiguity. Temporal means time. Contiguity means together. Together, physically together. Temporally together. Together. Butt up against each other. So you can't ring a bell and give a dog food an hour and a half later and say, oh, the bell and the food are going to be associated. They have to occur together. The bell sound and the food the animal getting food have to occur together in time. That time relationship will depend on the procedure that we use, which we will talk about in another lecture. Sometimes you need very small temporal contiguity, only a matter of under a second. Sometimes you could have maybe a minute, ring a bell, come back a minute later, give the animal food. You do that enough times, they're going to start connecting those two. So we bring two stimuli together in temporal contiguity. We do that many trials, many times. And then we look to see if there's a behavior that changes to one of the stimuli. The animal comes to associate the stimuli, and they show behaviors that change to those stimuli. So let's learn some terminology now that's used in Pavlovian learning. And so what he has is what's known as the unconditioned stimulus. Conditioned means learning. To condition something is kind of substitute for learning. So there are stimuli that don't need learning. They are innately reflexive. The animal just shows a response to it. They're born to it. You saw the little baby with the lemon juice? They didn't have to learn anything. They put it in their tongue and automatically it produces this grimace in their face and there's reaction. They also probably produce a lot of salivation. So if I have a dog and I give that dog a snack, I put it in its mouth, I give him some meat or even lemon juice, it's going to salivate, doesn't have to learn. Unconditioned, automatic, innate. Produces an innate response. Food in the mouth will make an animal salivate. Doesn't have to learn anything from it. Light to the eye is a reflex. An unconditioned stimulus, light, produces a reflexive reaction of the eyes constricting. We check babies, we check reflexes in babies. Put a little light in their eyes, see how their eyes react. If you give an animal a light shock, like a 1 amp shock, it's a little uncomfortable, but they're going to show a reaction to it automatically because it's a little uncomfortable. Rats will freeze, animals will pull their paw back if it's a dog, things like that. Unconditioned stimulus brings it in. Unconditioned responses are the measured response to the stimulation. An unconditioned response is a natural, innate response to an unconditioned stimulus. Unlearned, reflexive, innate. So, food in the mouth. Food is a stimulus. Lemon juice to the mouth is a stimulus. A light to the eye is a stimulus. Shock to the foot is a stimulus. Salivation to the lemon juice or to the food, salivation is a response, an unconditioned response. The eyes constricting, unconditioned response. The animal freezing or pulling his paw, unconditioned response. Sometimes an unconditioned response can just be more emotional in nature. So if I give my dog, let's say, a little bacon snack, she loves her little bacon snacks. She's going to salivate when that thing gets in her mouth. But also, she's going to be pretty happy because she really likes the taste. So an unconditioned response to something that tastes good is something that's not easily measured, but certainly a response, and that's kind of feeling good. This will become important when we talk about instrumental conditioning and training animals and training people. I'm going to ask you questions on exams where I say, what's the stimulus? What's the response? What's the unconditioned response? What's the unconditioned stimulus? You need to be able to identify them. The conditioned stimulus is a stimulus that changes in terms of the response that it produces. In experiments, we typically use a stimulus that is neutral or starts with no response. If I come up to my dog and I ring a bell, the dog will turn its head, look at me, but that's it. It's not going to salivate. It's not going to show fear. It doesn't have any meaning. So we talk about a stimulus that begins neutral, that doesn't really produce a response. But that's not always the case. We might have a stimulus that produces one response, and after association, after conditioning, after we bring it together in temporal contiguity with something else, the behavior to that stimulus changes. A conditioned stimulus is a stimulus where after training, the animal shows a different response than it did at the beginning. Conditioned stimulus. So a light, a tone, an odor, a symbol, something. Or something like food produces salivation, but if we connected some kind of novel food with making the animal sick, that food used to make the animal salivate. It used to be associated with something good. Now it doesn't salivate because it's not going to eat it. It changed, right? Now, the conditioned response, or the CR, is what we measure. It's our measure of learning. It is the response that we get to the conditioned stimulus. So let's think about this for a moment. Let's think about a dog. I ring a bell. It does nothing. The animal doesn't do anything. Just looks at me. Ring a bell. It's a conditioned stimulus. Does nothing. But if I have the bell and food and I pair them together, the bell will change its response. Its conditioned response. It will salivate to it. It is the performance measured as an indication of learning. This is what we use to say there's been some association, there's been some connection. Typically, the conditioned response is same as the unconditioned response. The animal salivates the food, now it salivates to the bell. It's similar. Not always. And we're going to have a lecture talking about, well, sometimes it doesn't do the same thing. It's still a measure of learning. So let's talk about the not always in a bit. Okay, here we go. Here's a dog. Let's think of Pavlov's work. And he's got this metronome. And it goes back and forth. Tick, 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 tick. It's producing a sound. The animal gets to see it. It's visual. And the animal looks at it and does nothing. It doesn't respond to it. Maybe looks at it. Might even habituate to it. Certainly not salivating to it. And then we pair that in temporal contiguity together. Tick, tick, tick. Here's some food. The animal's salivating to the food. So, what is the unconditioned stimulus? Food. What is the unconditioned response? Salivation to the food. The animal didn't have to learn anything. We're pairing the conditioned stimulus, the metronome, with the unconditioned stimulus, the food, in temporal contiguity. And we do that many times. Now, we're going to use the word trial a lot. A trial. If I do the metronome, I give the animal food, I stop for a few minutes. I've just done a trial. I'll come back in a few minutes. I'll do it again. Tick, 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 food. Trial number 2. Come back in a minute. Tick, 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 food. Trial number 3. I'm going to use the word trials a lot. After I've done this, trial after trial, we're going to begin to see salivation to the metronome. Didn't used to. Now it does. Why? Because it associated. The metronome became associated with food. When I hear the metronome, I get food. Doesn't even have to be at a conscious level. In some ways, the metronome might substitute for food. We'll talk about those theories in a bit. The metronome in a way is food, or it might just be a predictor. I'm not going to eat the metronome, but I know what's coming and I'm going to prepare. We see this all the time, right? I think I mentioned this in a previous lecture. Walk into Kentucky Fried Chicken. That smell is a conditioned stimulus that has been associated with the 11 herbs and spices and deliciousness. So when you smell that smell, believe me, your pancreas starts getting involved. You salivate in your mouth. Your whole digestive system begins to react because that smell is a predictor of food. Okay? Now, we're going to spend a lot of time talking about techniques for doing this. I just want to get some language down because we're going to use this language a lot in this class. All right, so that's the end of this. Now we're going to talk about different techniques used to measure classical conditioning. We're going to look at theories of classical conditioning, Pavlovian theory, and then some more modern theories and ideas about classical conditioning.